Hello everybody and welcome to our lesson on section 15C, the product rule. So far we've studied rules about adding and subtracting two functions, but not about multiplying two functions and taking the derivative. So it's very tempting to guess that if we want to take the derivative of a function where we're multiplying two functions, that we should just take the derivative of each function individually and multiply, but this does not work in practice. Instead, we use the product rule. So the product rule says if we have two functions that are being multiplied together, then the derivative is equal to the derivative of the first function times the second function as is, plus the derivative of the second function times the first function as is. And we can write it in either Lagrange notation or in dy by dx notation. So here's our first example. We have two functions that are being multiplied together, and we want to take the derivative. Okay, so what I'm going to do in the next little while is I'm going to show you how, I'm going to show you my plan for what I'm doing before I actually do it. So here I've indicated that I need to take the derivative of the first function by showing this prime times the second function as is, plus the derivative of the second function, indicated by the prime notation, times the first function as is. When I take that derivative, I take the derivative of 2x cubed and get 6x squared, plus the derivative of 5, which was 0, multiply it by the second function as is, and I take the derivative of the second function, which gives me 6x minus 1, that's 3 times 2x, minus 1 times 2x cubed plus 5, which was the original first function. Now there's no need to expand at this point or simplify. I can just leave it in factored form, or not factored form, leave it in this form. Okay, later on, if we have common factors, we will simplify more, and you'll see that in a further example. I'm just going to make this full screen. Here's another example of multiplying two functions and taking the derivative. So I need to take the derivative of the first function times the second function as is, plus the derivative of the second function times the first function as is. Notice that I've changed this to its exponential form so that I can easily take its derivative. I'm going to drop its exponent, keep the base, reduce the exponent by 1, multiply by the original second function. I'm going to take the derivative of this function, which is just negative 3 times root x. Okay, and then I'm going to tidy it up a little bit. I'm going to put this in the numerator of the fraction. I'm going to keep the 2 and bring this x to the 1/2 down to the denominator. And then, generally speaking, we don't like to leave radicals in the denominator, so I can multiply by root x over root x to try and tidy that up a little bit. Okay, one more example here. What about if I want to find the derivative here? I'm going to have to apply multiple derivative rules. So I'm going to need to take, and here I'm using the dy by dx notation. So I'm going to this d by dx indicates taking the derivative of this amount, or this value. So I'm going to take the derivative of x squared times x squared minus 2x to the 4th as is, and then the derivative of the second function times the first function as is. Okay, when I do that, I get 2x times this, and I get 4 times x squared minus 2x to the 3 times the derivative of the inside part here, which is 2x minus 2, times the original first function x squared. Now, here I notice that I have some common factors. So I can simplify this expression. I'm going to common factor out a 2x and an x squared minus 2x all cubed from both terms. If I divide this yellow term by this amount, I'm left with just one x squared minus 2x. And if I divide this green term by this amount to common factor it, I'm left with 2x times 2x minus 2. And I can simplify that. I can expand and drop the brackets, and then I can collect my like terms. That's it for the product rule.